So last time we talked about length. 13.1 was how long things are. Now we're going to talk about area, space in the middle. Like if you go to order a new tile or carpeting for a room, we're talking about area, not length. See the difference? If I just have a rectangle and I say, okay, well, if I just have a if I just have a length, so this is length, one dimensional. But if I have a rectangle and I want to know how much space inside, that's two dimensional, isn't it? So now in 13.2 we're going two dimensional. Next week we'll go three dimensional. We'll have volume and surface area. So today, two dimensional, length and width. So if you go to the store to buy new carpeting or tile, they'll ask you how many square feet you need of carpeting or tile for a room. So why are they talking square feet? I think you know, because it's squares, huh? It's literal, actual squares. And we're going to do some of this on Wednesday. I'm going to bring a handout, because I think I want to do a little bit more hands-on work in here. I think the exam told me it'd be beneficial to do a little bit more hands-on. So starting Wednesday, especially this chapter also really lends itself well. The second half of your homework, we're going to do right in here. I'm just going to give you handouts of the harder ones, and we'll do it on Wednesday at your tables and do it that way. So you'll see the actual squares. And so just looking at this rectangle here, I think you can see it already. If somebody gave you a rectangle and they said, okay, got this rectangle, can you see that one there? Yeah, you can see that one there. I'll just say this one. And its length is 4, and its height is 3. Does everybody see that? How that rectangle is 3 by 4? Right? There's 3 squares tall. 1, 2, 3 squares tall. And it's 4 squares wide. 1, 2, 3, 4 squares wide. So it's 3 tall, 4 wide. How many total squares in there? Yeah, going to be 12, huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so it's a 3 by 4 rectangle. It has 12 square units, 12 square feet. So we would say it's made, the area of that rectangle is 12 square feet. And a square foot is a 1 foot by 1 foot square. So they're saying there's actually 12 square feet located in that rectangle. That's the area of that rectangle. And so I think the formula is pretty natural. What's the formula for the area of a rectangle? Yeah, do you see how you just take the 3 and the 4 and you multiply them? I think it's real natural, right? And I think you can appeal to younger folks. It's always best if math makes sense for them rather than just random formulas, right? If you showed this to somebody and said, look, we have 3 rows of 4. How many total squares do we have? Pretty much everybody go, it's 3 times 4. And that's exactly how we get the area formula for a rectangle. It's just one side times the other, isn't it? Just 3 times 4 on that. So that's the area of a rectangle. We're talking about actual squares. How about for a parallelogram now? Do you see that a parallelogram is just a shifted rectangle? Its formula is going to be the same as a rectangle. If you take that parallelogram, I always imagine it made out of Jell-O. So that rectangle is made out of Jell-O, let's say. We got these 2 sides here. If you shift it, it's a rectangle. Parallelogram is just a rectangle that's been shifted, or they're showing in this picture, you could just take this chunk here and move it right there. See how they moved the blue chunk over there like that? And they made it into a rectangle. They just cut off one side and moved it over. And that doesn't lose any area, does it? That's got to be the same space inside. So the area formula for a rectangle, for a parallelogram, is the same. You just call it base and height, but it's basically the same. Parallelogram is just a rectangle that's been shifted. All right, I'm going to give you these formulas kind of quick and get to the homework for you. In fact, actually, let me just give this one. Do you guys know the area of a triangle formula? A half times base times height. You've seen that one before? One easy way to see it is if you take a triangle like this that has a base and a height. if I put another triangle the same up here, then my diagram's not the best, then we've got a rectangle, don't we? So that's a rectangle now. So do you see that the triangle, the original triangle, is just half of the rectangle? That's where we get the half in the formula for the triangle. So a triangle is just half a rectangle. Half a base times height. And now, is that good? Questions I can answer on that? See where that formula is coming from? And then trapezoid. A trapezoid, what they're showing on that picture is that if you take the top and the bottom of the trapezoid and you kind of push them together, you make it into a rectangle. See how that diagram is again showing that they took this piece here and they move it right there and they make that thing into a rectangle. But it ends up averaging the bases. Let me leave it like that for now. We'll talk about it more. I think we need to get hands-on more with this stuff. So there's the formula. We'll just leave it there. I'll talk more about why that's the truth. And after we've been working with these things more up close, I think. All right, let's with that. Oh, circle. I forgot about circle. Area of a circle, pi r squared. That's different than the circumference. Circumference is around the outer edge, isn't it? Circumference is around the outer edge. That was 2 pi r. Those formulas are really similar. They both have the same three pieces, but area is the space in the middle. So this is area in the middle here. And area is pi r squared. Circumference around the outer edge is 2 pi r. Very similar, have the same three pieces. And then there's the converting chart again. Same one we had last time, because we're going to start with conversions. So with that, let's, and then there's some crazy units. We'll come back to those. All right, let's dive in. So let's start with converting. We're going to convert in metric and English. Probably about all we'll have time for today is converting in metric and English. Metric again is going to be super easy. The English is more challenging. So let's start with this 558 square centimeters. Now we did some of this last time in 13.1, but now we're doing it for area instead of for length. It's actually almost the same. It's hardly any different. It'll be very easy for you. Let's jump from square centimeters back to square meters for starters. I'm going to write down that chart again for us. Remember there were, let's see if I remember. There were kilometers, hectometers, decameters, meters in the middle. What was it? Decimeters, centimeters, millimeters. Yeah. Okay. So if we jump from square centimeters back to square meters, so they're telling us they have something that's 558 square centimeters. That's the area, 558 square centimeters. So how many square meters is that? Well, let's give it a try. So if you're going to jump from centimeters back to meters, that's 2 jumps to the left. So I'm going to take that 558 square centimeters. Where's the decimal right now? When we don't see the decimal, where is it always? At the end. It's right there, right? So it's right there. And so I'm going to take that decimal, and I'm going to jump from centimeters back to meters, which is 2 jumps to the left. But this is area. So does anybody already know? What do you do when you're doing area? Instead of just going 2 back.
2 squared back.
Yeah, well, you just double it. Yeah, so it'll be 4 back. That's all you got to do. You just double the amount of jumps. When you're doing area, you just count the jumps and double them. So if instead of 2 back, it'll be 4 back. So we just go 1, 2, 3, and I'm to the edge. 4, I bring in a 0. So it's going to be 0.0558 square centimeters. Is that good? So everything's the same as how we were converting last time. You just double the number of jumps because you're doing area, because it's not just centimeters, it's centimeters by centimeters, right? They're squared. There's 2 of them. So you just double it. Let's go to And I think, did I say that here? Yeah, there it is. Double the number of steps. That's what I'm showing you in your notes. For area, you just double the number of jumps. Okay, let's try going the other way. Let's go from square centimeters to square millimeters. So let's again start with 558. Square centimeters, and we want to go to square millimeters. So from centimeters to millimeters. So we'll go one jump to the right to go from centimeters to millimeters. So again, where's the decimal? Whoops, erase that. Where's the decimal right now? It's at the end, right? Sorry, I got messing up all my diagram here. So it's at the end. And so if we go one jump to the right, that means I need to double it. So 2 to the right for the decimal. So those are both beyond the edge, aren't they? So they're going to bring in 2 zeros. So this will be 55,800. Is that making sense? So one jump to the right, double it, 2 decimals to the right. And whenever you go beyond the edge of the decimal, it always brings in zeros. Want to try part B there? Area of a cross-section of a dowel. It starts with 162. 162 square millimeters. Can you jump back to square meters and square centimeters? All right, so if the decimal... So the decimal is at the end, right? Remember, whenever we don't see the decimal, it's like a period in a sentence. If somebody forgets to put on the period, you know it's at the end of the sentence. It's always at the end when you don't see it. And then if I'm going to jump, back to centimeters, I'll just do that one first off. That's going to be, so from millimeters back to centimeters is just one jump to the left. But then we double it because we're doing area. Guess what we're going to do next week when we do volume, which is 3-dimensional? We'll triple it. So easy. Metric system is so easy. Just double the jumps for area, triple the jumps for volume. Yeah, so we do. If so, one jump to the left, double it. So that's 2 decimals to the left. That good there so far? 1.62. Okay, and now, if we want to go all the way back to square meters, oops, I'm erasing everything here. Back to square meters, so that's going to be more jumps, isn't it? So for square meters, it's 1, 2, 3 jumps to the left. So double it, 6 decimals to the left, huh? So go back to where it started, 162, the decimal starts here. I'm going to go 6 jumps to the left. So 1, 2, 3, and I'm to the edge of the number. 4, 5, 6. Those bring in zeros, don't they? Does that make sense? So 3 jumps on the metric chart, double it, 6 decimals to the left. The first 3 get you to the edge. The other 3 bring in decimals. So it's going to be 0.000162 square meters. The rest are the same. Not too bad? Now we got to go to English. So with metrics, we always just use decimals. With English, what do we have to use? Yeah, conversion tables and fractions, huh? You see? I mean, it's an easy question. What do you like better, decimals or fractions? For most people, that's decimals. Decimals are a lot easier. Well, that's the metric system. It's just decimals. Why is it that way? They made the measurement system base 10, so it would fit our number system base 10. They fit, so we can just move decimals. Whereas English, we got to use fractions, which are harder. All right, let's go to the English. We're going to take 4,000 square feet and change it to square yards. So let's go there. So this will be, gets a little space here so we can work. Yeah, these are all the ones we're going to do tomorrow, all these kind with dot charts, on Wednesday. Okay, so number 2, part A, was it 4,000 square feet, and we're going to square yards? Okay. Yeah, so how are we going to do that? Well, it's pretty much exactly like what we did before. Got to put it over 1, got to multiply by fractions to get things to cancel. Remember, it's all about canceling. And so what does that mean? I'm going to put what where? To get, Yeah, so start with, and where's feet going to go, on the top or the bottom? Got to go on the bottom, because we got to get feet to cancel, huh? Yeah. Now, what about the fact that it's squared, though? Well, we'll handle that in a minute. Let's just kind of set that aside, and let's just do our regular thing first. Feet on the bottom. So if feet are on the bottom, what can we go to? What do we want to go to? What do we have to go to in the end? Yards, right? We're going to yards. So I'll put yards on the top. So everybody see how I knew to put feet on the bottom? Because you want feet to cancel, and we're going to yards, so yards go on the top. Yeah, what's the connection between feet and yards? Yeah, do you remember it? 3 feet is 1 yard. 3 feet is 1 yard. Now, again, nothing is squared yet, right? What about the fact that this is actually squared feet? Now that you have it all in place, you have to square everything in the new fraction. What I mean is we want square feet. So we have to square the 3 and square the yard and square the 1. Everything. Square everything in the fraction. And then it'll work just fine. So in other words, now, square feet will cancel square feet. And then, now they're weird on this question. I think they're weird. They want a fraction answer. The rest of them, they'll let us do decimal. So they want a fraction. So on the top, it's just going to be 4,000. On the bottom, it's just going to be 9, and we're done. So everybody see how I got 9 there? 3 squared. 3 times 3. And the 1 squared is just 1. The 1s aren't doing anything. They won't multiply by 1 or dividing by 1 doesn't change it. So that's how they want the answer. As weird as that kind of looks, they want it just like that. 4,000 over 9.
They don't want a mixed number this time.
They don't want what? Mixed?
Last time they made us do a mixed number.
Yeah, I know they show a mixed number as the answer. I think they will take it this way as well.
Okay.
I'm not 100% sure, though, honestly. Cammy, I might be wrong. But they said simplified fraction. This is a simplified fraction. Yeah, so if they want mixed, then you'll have to divide and make it mixed. All right, let's go. Let me show you. You would know how to make that mix, right? You would just divide in your calculator, right? You would, if they want to mix, you can just go 9 into 4,000 and just use your calculator real quick. I have no idea. What is 4,000 divided by 9? And just get the whole number there. It is 444. So 444. I just take the whole number part. I don't care about the decimal. Yeah, so let me show you real quick how to, and then I just go back and I go 444 times 9, and that comes out 3. Then I just multiply. I went times on my calculator. 3996, subtract remainder 4. So that means 444 and bottom over left and 4/9 square yards. Yeah, so in case they want mixed, there would be how you do that. To get a mixed number, you just have to long divide. See, I did the bottom into the top, and then just use my calculator really to give me all the numbers. So, all right, let's go on. So the rest of them, they'll let us just do decimals. So for part B down here, part B, let's see what we've got. For part B, it's, they're doing weird things with powers. 10 to the 8th square yards. 10 to the 8th square yards. Okay. So 10 to the 8th square yards. And they want me to go to square miles. Wait, square yards, huh? Square yards. And they want me to go to miles. Okay, well, I didn't put we had it last time, the conversion. What is it? 1 mile is 1760? Is that what it is?
Yeah, 1760.
Yards from last time. So we need to use that again. 1 mile is 1760 yards. Let me move that down a little bit. 1 mile, 1760 yards. Okay, so let's put this over 1, multiply. Okay, so remember, what are we going to do as our first step? We're going to put, where do yards go? On the bottom. And then we'll put the miles on the top, and we'll say 1760 yards in 1 mile. But nothing's squared yet, so what do we have to do? Yeah, we have to square every piece like that. Square the numbers, square the words, and then then it'll work. Then we'll get the yards squared canceling, and we'll be in the miles squared. Okay, great. I got all that. But how do you actually get an answer? They don't want a fraction, thankfully, this time. They'll let us just give them a decimal, which seems much more reasonable. And so how do we actually do that? Well, you're going to need to do the 10 to the 8th and then divide by the 1760 squared, right? The 10 to the 8th is on the top. Anything under the bar, we just divide, right? Now, do you guys know how to do powers on your calculators? So every calculator is a little different. I'm glad to help. It just takes 10 seconds if you come up after class if you have any trouble. Maybe I can bounce around even right now. 10 to the power. Now the power button, some calculators it's X to the Y. Some of them it's like an up arrow. And then divided by, and then same thing on the 1760, the X to the Y or the up arrow to and he equals. I'll do it also and tell you what answer I'm getting. I'm getting 282.283 square miles. Let's go back and get the units for acres and square feet. Here they are. I put them on your chart. There it is right there. 1 acre is 4840 square yards. 1 acre, 4840 squares. So there's the units you need are right there. So 1 acre, 4840 square yards. So write down here, 1 acre, 4840 square yards. All right, can you convert that one? Maybe I better do it because we only have a minute. So this one's over 1. Let me just do it for you real quick and we'll be done. So where am I going to, what's my first step? So here we are, and this is a good point to see, this is like how I survived physics, is I'd be in some weird new setting, which I really didn't understand completely, but I would just follow the trail of the units. So acres are on the top, so where am I going to put acres? On the bottom, yeah. You don't have to know everything in the world, just for sure got to do that, right? Now, what could I go from acres to? Can I go to square feet? Well, no, I don't know that connection, but I know this connection. This is what they gave me on the chart. So just take what they gave you. Don't do something fancy. Just take what they gave you. So I go, okay, well, I'll just do that. 4840 square yards is 1 acre. That's just exactly what that says, huh? And I was able to write the square. I didn't have to put the square later, notice. It was already there. So if it's already there, you don't have to square. I'm not going to square that 4840. That means it's already prepackaged squared for you. Does that make sense? Everybody see the difference? Whereas on the last problem, I started with, 1 yard is 3 feet. Nothing squared. So I had to square them all. Whereas this one comes prepackaged, already done. Okay, if I stop right now, I'm in square yards. So I got to get rid of those. Yards on the bottom. What goes on the top? Feet, because I'm trying to go to feet. What's the connection? 1 yard, 3 feet. None of that is squared yet. That doesn't come prepackaged squared. So square it, square it, square it, square it. Square yards cancel. Take your calculator. 2 times 4840. Everything's in the top, so it's all times, right? Times 3 squared, which is just 9, huh? Just hit the buttons on your calculator. You'll have the answer. That quick. Just follow the unit trail. All right.